Alright, let's work with the next type of differentiation, that is logarithmic differentiation. Here we have a little different type of functions. It's not about quotient rule or chain rule or product rule, but we have some special type, right? So let's go. What if you have a function like y is equal to sine of x into sine of x into cos of x? We understand, we use product rule, UV rule, right? So what if we have a function like y is equal to sine of x to the whole power cos x? Now we have this function on the power of sine, right? How do I differentiate this? We can't use product rule, quotient rule or chain rule in this. Now the first thing and the best thing is to get this guy down. So let's say log of a to the power b. This is something which you learned in your first POC in logarithms, right? So if at all I have something like this, I can write this as b log a. You should be knowing this formula, very simple. Now b, which is on the head of a, would come behind the log and multiply with that. So using that, what happens? If I take log on both sides, log of y is equal to log of sine x to the whole power cos x. So what happens to cos? Cos would be just multiplied with log of sine x, and it would be on the same lines. Alright, and nothing is on the power of another function. So now this whole guy looks like a u into v function, that is product rule. This can be differentiated easily with the basic rules what we know already. Okay, so now on the left hand side I have log of y. Can you differentiate this guy? Yes, let's go ahead. Right, so this guy looks more like u into v, and this is a chain. Alright, so I can write 1 by y into dy by dx, which we already know, is equal to, I'll write this as product rule, that is cos of x, and differentiate, that is log of sine x, yep, and plus log sine x. I'm using the basic rule of product here into differentiation of cos x, and that's it. Now where all we sign the dy by dx sign, so we need to differentiate that particular function, right? So go back to the belting rule. If you remember the starting of the session, we'll learn the belting rule. If you have two guys like this, let the first guy stand, belt this guy, and let the second guy stand and belt the first guy, right? So that's how it works. So I have 1 by y, dy by dx, this is what I'm looking for anyway, is equal to cos of x. And how do I differentiate that? So 1 by sine x into differentiation of sine x is cos x. This is a small chain, the log chain basically, right? The next thing, plus, and I have log sine x, nothing to differentiate here, so I'll just write it like that, into differentiation of cos x is minus sine x. That's all is what it is. Now I need dy by dx only. What about this y? So I would multiply this y on the other side, that is y into this whole thing, that is cos squared x by sine x plus log sine x into minus sine x. I can multiply this minus sine x here. Anyway, who is y? Y is my question, so I can write this as sine x to the whole power cos x into, I can write this as cos squared x by sine x. I can simplify it further using trigonometry, not a problem, but I can write this as plus into minus is minus log of sine x into sine x, and that's all about it. So these are the functions where I have a function to the power of another function. So first thing what I have to do is to get that function down here, right? This we can do using log. This is one of the basic rules of logarithms where I can actually use to get the function which is a power of the other function down. Okay, now let's do another problem. Let's say y is equal to sine x to the whole power, let's say this time sine inverse of x. Okay, sine x to the power sine inverse x. Now what is the first thing to do? Get this guy down. Alright, so I can use log of a to the power b is what? B log a. This is what I'm working on with. To get this function down on the same lines, then it becomes product rule. Simply differentiate that. So can I use the same thing here? So I will write log of y is equal to log of sine x to the whole power sine inverse of x. So what happens here? I can see that this is 1 by, or let me write is log of x and log of y. I'm not differentiating still. This guy would come behind, that is sine inverse of x into log sine x. And now this looks like UV rule, that is product rule. Can I differentiate that? Let's do it here. In this case, I have u, that is log of y, let it be here, and sine inverse of x. I'll just copy the question into log sine x. I'm taking this whole thing as u, and this is v, and here is a small chain with log. So how does the chain open? 1 by y into dy by dx. That's how it works. And this guy is product rule, that is sine inverse of x. Differentiate log sine x, yep, plus log sine x into d by dx of sine inverse of x, and that's it. Alright, so this is basic product rule I'm using. Now what happens here is I keep sine inverse of x here, differentiate this guy as 1 by sine x into differentiation of sine x is cos x, that's it, plus log sine x. I have nothing to do here with differentiation, so just keep it like that. And how do you differentiate sine inverse of x? That is 1 by root of 1 minus x squared. These are your basic formulas which you learned in the starting. Alright, so now here on the left hand side I have 1 by y into dy by dx. What happens to the y? Y would actually be multiplied here, so I can write it like y into this whole thing, correct? Yeah, who's y? Y is my question, so I can substitute y back as sine x to the whole power sine inverse of x into this whole thing. This can be written as cot x, so sine inverse of x into cot x plus log of sine x, the whole thing divided by root of 1 minus x squared. Okay, that's your simple answer. Right, so let's do another problem. Okay, this should be enough to understand what logarithmic differentiation is. It's only simple stuff that you have two functions, one on the head of the other or one as the power of another function, and our first job is to get those functions in the same line and make it a product rule and differentiate, nothing much. So would you like to try something? Let's say we have x to the power sine inverse of x, or let's say tan inverse of x this time. So I have two functions, x is one function, tan inverse another function. So how will I get tan inverse in the same lines? Use log on both sides, that's it. So this is a very simple typical type of problem. Whenever you have this, take log on both sides, that is log y is log of x to the power tan inverse of x. What happens here? Log y is equal to tan inverse of x into log of x, and that's it. So now I can see these guys look like the product rule, and let's differentiate that. So this goes like 1 by y and dy by dx is equal to u, that is what? I'll keep it here, tan inverse of x into d by dx of log x plus log x into d by dx of tan inverse of x, that's it. So let's go ahead. This is this y, can I say that? Yes, dy by dx, I'll keep it like this, is equal to y into who's y? I'll substitute y as my question in the next step. So this is tan inverse of x, and how do you differentiate this? That is 1 by x, very simple, plus log x, and the differentiation of tan inverse of x is what? It is nothing but 1 by 1 plus x squared. Yeah, that's it. And who is y? I can in fact substitute y as my question, that is x to the power tan inverse of x, and that's simply my answer. I hope you get this. Very typical way of guessing which type is this. If at all you have a function on the power of another function or the head of another function or exponent to the another function, what we do is we get this function down. All right, we get this tan down using which log? That is log of a to the power b can be known as b log a. So when the guys are both on the same lines, I can use the product rule and use the same basic rules what we learned before this. That's all about log. We have another interesting thing connected to log differentiation we'll see in the next video.